rockers, because iron doesn't float. People made boats out of wood. Well, here's this clay. It has the same weight. Watch this. Oh, yeah. Yucko! Yeah, look at it now, gang. Isn't that nice? Now it's being held up by what? My fingers. You get the idea. Concentration of force is pressure. So let's talk about that, gang. Pressure, definition. Screwed up. I don't want to talk about pressure. I want to talk about density first. You guys, can you come in on Wednesday? How do we find the center of gravity of different things? Well, the book's easy. How about something like this? There's a way. And the way is very easy. Let me show you. All I got to do is suspend it. Suspend it by that point. Guess where the center of gravity is, gang? It's somewhere beneath this line. Okay? Over here. Somewhere in here. Now, let me try this again, gang. Troy, I think our board is insufficient. Let me try this again. Let me hold it from here, gang. Center of gravity is somewhere along there. And I can see if that's true by seeing if it will balance. And it does. So it's somewhere along there. Where along there? I can hang it by another point and find out that it's... Troy, the center of gravity of this board is within the board. That blows everything, gang. I don't know what to do. Yeah, the board's too fat. Look at the globe here. In the summertime, Amsterdam's way up here. Okay? Now let's suppose we have an imaginary line right in here about where darkness is, okay? Everything to this side here is dark, because let's suppose the sun's coming in this way, okay? Sunlight's coming in. Well, let's look at Amsterdam way up here. Here they are right here, okay. First of all, the sun comes up. Here they are. Day, 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 day. Night, 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 night. Day, 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 day. Most of the time, they're in the sunlight. The sun come right in here. I've got this wrong. I've got this wrong, gang. I've been doing that. In fact, when I get over here, I had to start, wait a minute. Do you see I screwed up? I screwed up. What was my screw up? Check the neighbor and see how Hewitt screwed up. How did Hewitt screw up? Come on, check the neighbor. How many said, it looked all right to me? Come on. How did I screw up?
Turn it over.
Oh, for television. Okay, it's got 24 times as much area to feed itself. But what's wrong with that, gang? 24 times as much area is feeding how much more cell? 1, 2, 3, 4, 5, 6, 7, 8. 8 times.
Oops, that was 24.
Hey, I'm mixed up. Yeah, 8 times as much.
4 times.
Oh, now I'm mixed up, gang. I'm getting mixed up.
It has 4 times as much total area because 24 is 4 times 6.
4 times 6. That's where I screwed up. What I'm gonna do? What I'm gonna do? How did we start that? Thanks for bailing me out again, Lee. What are we talking about, Ted? I'm self-conscious with his cameras on.
Cells getting bigger and bigger.
Huh?
Cells getting bigger and bigger.
Oh, yeah. You guys get freaked out with this thing looking at you a little bit. How about me? Yeah, okay. Okay. Living cell. Okay. Gets bigger and bigger, right? Let's suppose a living cell gets double the size. What do we got here, gang? What do we got here?
Trouble.
I've got a tablecloth. I've got a tablecloth with no lip. Okay? Watch this. Those dishes are essentially at rest, aren't they? Here's something for you to do this weekend when you finally get invited to your friend's house for dinner, okay? And a friend wants to know, what are you doing? What are you doing at school? You can kind of show them this, right? You don't want to try this at your own house, not with your own dishes, okay? You might mess, but you try them at your friend's house. How about this, gang? What's going to happen if I pull this thing very, very quickly? Huh? What's going to happen? Let's try it. A 1, a 2, a 3. And there you see Newton's law, flawlessly executed. That distinction between weight and mass, I can kind of show you that kind of neatly with this device. What I'm going to do is take this heavy ball or massive ball? Both, yeah. See? I'm going to take this ball. It's got a lot of mass. Also has a lot of weight. Okay. And what I'm going to do is I'm going to take one of these strings on the bottom. You can see I've tried different trials here. And I'm going to pull. I'm going to pull until one of these strings, either the bottom one or the top one, is going to break. And what I want you to do is I want you to guess, hypothesize, which string, the top or the bottom, will break with a gradual tension increase at the bottom. Check your neighbor. Okay, when I pull that very, very slowly, gang, which string going to break, top or bottom? Top one? How many say the top? Let's try it.
Maybe Newton's having a bad day.
You know what that might have been? That might have been a string before that we partially damaged.
Yeah.
Probably.
Can we start to tape?
Off at an angle like that, doesn't it travel a greater distance than the one that's just falling vertically? So for him to hit at the same time, it has to be going faster. The object has to be traveling faster.
It turns out if I jump off the lanai like this, or step off like this, or step off like that, I'll hit at the same time in all cases. Over here I'll be going faster because I have a bigger speed like this, and that arrow is going to be bigger than this, Be faster, but I've gone a further distance. And later on we'll talk about a neat concept that'll tell you that down here, wait a minute, I will not be going faster. Erase the tape. Lionel, that's wrong. It turns out I'll have the same speed here, here, and here. No, I won't either. Lionel, the tape's okay. Leave it going. All right. Get a little mixed up. You guys get mixed up with this stuff? I'm all the time getting mixed up with elementary physics. So if you guys get mixed up, don't feel bad. I'm with you, all right? With this clip, I'm going to fasten the point to here. Now, I'm going to crank this again, okay? If you see a lightning bolt from here to here, if you see that, Scout's honor, A in the course. If you don't see that, then you got to do your exams and study and da-da-da-da-da, okay? So let's try it now. It's almost as if there's a spark there, isn't there? This is most unusual.
Try switching to the other side.
No. Gang, I have no explanation for this. This is new to me.
Can you put it on the other side?
It should
That should. Yeah, there.
should be less probable, but you see, it's got a leak from one to the other. I wonder if it's because I didn't discharge it to begin with. Let me try something.
Oh.
But it was continuing to charge.
Does it matter the way you crank it?
Continuing to go.
Yeah, it does. Turns out it does. Yeah. But I could. You crank it counterclockwise. Okay, watch this now. It shouldn't do. That blows me out. That blows me out. This has never happened before. I've never noticed this. And if it leaks off that point, then it should drift over here without having that snap, snap, snap. And it's not happening.
When you put the 2 points on it, you turn it the other way.
Oh, well, I didn't mean to do that, but...
Say the worst. That would be really well.
No, but...
Maybe we should discharge this first.
oh, my God. I notice everyone out there seems to be pretty happy today. You seem to be pretty happy because you see the old fool up here making a damn fool out of himself, right? You guys should all be saying, oh, gee, what? So we could, yeah, we can test to see whether things are true. If I bring a positive object nearby, shouldn't the positive object attract the negatives and pull the negatives from there? And shouldn't the leaves collapse? One of the nice things about science is you start to understand it, you see if you can predict things. And if you can, then it tells you that your theory probably is more likely correct than more likely wrong. Let's try that, gang. If this is more positive, oh my God. Why does it still diverge more? That blows me away, gang.
Is that coming together, or is that?
It's getting more and more divergent. And it should collapse when I bring this over. It should. What do you mean it should? It's doing what it should. My explanation is just off, right? Look at that! Oh, I've got nothing to, I'm supposed to be teaching you guys electrostatics. I've got nothing to say. In fact, probably everything I say is just all canned crap. because, honey, it's just not doing. Look at that. I got nothing to say. I could talk about Coulomb's law a little bit, but I don't believe in it anymore. Let's continue as if everything were going smooth. That's called make-believe.
I thought science was all about making discoveries.
Oh.
Experimental and
We could continue with this, couldn't we? We could continue and maybe find something fundamental, but it's not part of my act.
But if we're sitting in the classroom.
Well, okay. Let's move on, Kay. I don't know. Someone's going to give me an explanation of what's happening here, and I'm going to be very impressed. Who is going to be the one? In fact, that could be like a term project. What went wrong tonight? Who's going to say, Hewitt, nothing went wrong at all. What happened was ... What went wrong was your failure to be able to observe and interpret what happened to Hewitt. Nature's not wrong. You is. Okay? Someone write it up, because I am baffled, gang.